Today's video is the second series on the various types of systems that occur in the domain of signals and systems. What are the different types of systems? Static and dynamic, causal and non-causal, time invariant and time varying, linear and non-linear systems, stable and unstable systems, invertible system and non-invertible system. The last three are going to be the discussion of this video, as the other three have been already discussed in the previous video. What is a linear system? A linear system obeys the principle of superposition and homogeneity. Examples of linear systems are filters, communication channels, etc. What is homogeneity? If there is an input x of t giving an output y of t, homogeneity principle states that if the input is multiplied by a constant a, the output is also multiplied by the same constant a, as can be seen here. In other words, if the input is multiplied by b, the output is also multiplied by b, and so on. Let us go on to see what is going to be superposition. Superposition is going to be applied to a system which produces an output y of t for an input x of t. Since it is superposition, it is quite evident that we require two inputs and two outputs. Hence, we could see that input x1 of t produces an output y1 of t, and another input x2 of t is required to produce output y2 of t. So, the principle of superposition is going to be such that the input sum is going to be such that it results in an output sum, as can be seen here. x1 of t plus x2 of t results in y1 of t plus y2 of t. So, now if we are to combine homogeneity and superposition, what would be our result? As per the superposition, we have input x1 of t producing an output y1 of t, and another input x2 of t producing an output y2 of t. And from the homogeneity principle, we would recall that a into x of t would result in a into y of t. Hence, combining homogeneity and superposition, the net effect of a linear system would be the weighted sum of inputs a into x1 of t plus b into x2 of t results in weighted sum of outputs, which is going to be a into y1 of t plus b into y2 of t. Hope this is now clear what is the requirement of a linear system. This is the expression for a system to be linear. Hence, now let us go on to see what is it mathematically represented as. It is represented as any transformation t with ax1 of t plus bx2 of t results in a into the transformation of x1 of t plus b into the transformation of x2 of t. The same thing is also applicable for the discrete case with n, that is t into ax1 of n plus b into x2 of n results in a into tx1 of n plus b into tx2 of n. Let us go on to consider some simple problems to identify linear and non-linear systems. First problem is y of n is going to be equal to x of n into cos omega n. What are we supposed to do? We are supposed to find out the weighted sum of inputs and the weighted sum of outputs. Let us try to start the first case. The weighted sum of inputs is a into x1 of n plus b into x2 of n. Y of n gives two inputs represented by y1 of n is going to be equal to x1 of n into cos omega n, and y2 of n is going to be equal to x2 of n into cos omega n. Hence, extending the definition of linearity a into x1 of n plus b into x2 of n, it results in a into x1 of n plus b into x2 of n cos omega n results in a into x1 of n cos omega n plus b into x2 n cos omega n. Let us go on to see what would be the weighted sum of outputs. The weighted sum of outputs would be represented as a into y1 of n plus b into y2 of n. Let us substitute y1 of n and y2 of n here, since the expression is going to be resulting in a into y1 of n is x1 of n cos omega n and y2 of n is x2 of n cos omega n. Substituting it here, we would be getting it as a into x1 of n cos omega n plus b into x2 of n cos omega n. Comparing 1 and 2, we get that both of them are same. Hence, our conclusion is that the system is linear. Let us go on to consider one more problem to identify a linear or a non-linear system. The question given is y of n is going to be equal to n into x of n. We are now familiar that for a system to be linear, we require two inputs and two outputs. Hence, y1 of n results in n into x1 of n and y2 of n results in n into x2 of n. Going by the expression, weighted sum of inputs is a into x1 of n plus b into x2 of n. This results in n into x1 of x of n, which is going to be n into the sum of these two, which is going to be, as can be seen here, n into a x1 of n plus n into b x2 of n. Next is, what could be the weighted sum of outputs? For considering the weighted sum of outputs, the expression is a into y1 of n plus b into y2 of n, and this is going to be equal to a into y1 of n is n into x1 of n, y2 of n is n into x2 of n, and hence this would be a into n x1 of n plus b into n x2 of n. Since these two are constants, we could write them as same. Thus, 1 and 2 are same, resulting in that the system is linear. Let us go on to see what is a nonlinear system. A system which does not obey the principle of homogeneity and superposition combined is going to be a nonlinear system. This is exactly what has been written here. The previous expression which was available is again rewritten with an unequal sign, which means t into a x1 of t plus b into x2 of t is not going to be equal to a into the transformation of x1 of t plus b into t x2 of t. Same is extended for a discrete case where we write it as t into a x1 of n plus b into x2 of n is not equal to a into t x1 of n plus b into t x2 of n. Let us go on for some simple problems for identifying linear and nonlinear systems. The problem considered here is y of n is going to be equal to log of 10 x of n. As is seen in the previous case, we will be having two inputs x1 of n and x2 of n, resulting in two outputs y1 of n and y2 of n. Hence, y1 of n is going to be equal to log of 10 modulus of x1 of n and y2 of n is going to be log to the base 10 modulus of x2 of n. Let us apply weighted sum of inputs. So what happens? When we apply the weighted sum of inputs, it is a into x1 of n plus b into x2 of n modulus sign log to the base 10. Weighted sum of outputs results in a into y1 of n plus b into y2 of n. That means it would be a into log of 10 x1 of n plus b into log of 10 x2 of n. This is exactly what we have got because y1 of n is log of 10 x1 of n as is seen here, and this is log of 10 x2 of n, and hence this would be a into log 10 x1 of n plus b into log 10 x2 of n. Hence, when we compare the first and second expression, they are not equal. Hence, the system is non-linear. Let us go on to one more problem to identify linear and non-linear systems. The question given is y of n is going to be equal to x of n into x of n minus 2. As can be seen in the previous cases, there will be two inputs resulting in two outputs. Hence, y1 of n is going to be equal to x1 of n into x1 of n minus 2, and y2 of n is going to be equal to x2 of n into x2 of n minus 2. Extending weighted sum of inputs, which is going to be equal to a into x1 of n plus b into x2 of n, we would be getting this as a into x1 of n plus b into x2 of n into a into x1 n minus 2 plus b into x2 n minus 2. What would be the weighted sum of outputs? The expression is a into y1 of n plus b into y2 of n, which means it is going to be a into x1 of n into x1 n minus 2, which is the definition of y1, plus b into the definition of y2, which is x2 of n into x2 of n minus 2. Thus, the two expressions are not same, resulting in that the system is non-linear. Next, let us go on to the next type of system called as a stable system. In order to understand a stable system, we need to understand what is a bounded signal. A bounded signal is one whose magnitude is finite, example, a sine wave. And a system is said to be bounded input, bounded output if stable, if every bounded input produces a bounded output. Even if one of the input becomes unbounded or the output becomes unbounded, which means tends to infinity, the system is not going to be stable. In other words, the output of a stable system is going to remain within a certain finite range. It does not diverge or it does not grow large. Next, we need to see what is going to be the bounded input, bounded output stability criteria. The necessary and sufficient condition for bipole-stable is given by a definition of an impulse response, and an impulse response is the response of a system when a unit impulse is applied to a system. Hence, the mathematical expression for this is integral minus infinity to plus infinity h of t modulus dt is going to be less than infinity in the continuous case, and in the discrete case it is summation n equal to minus infinity to plus infinity. Absolute value of h of n or modulus of h of n is less than infinity. This indirectly means that the impulse response is absolutely summable. Let us go on to understand simple problem to understand the stability and unstability concept. The problem given is h of n is going to be equal to 2 power n u of n. The condition necessary to be proved is that summation n equal to minus infinity to plus infinity, absolute value of h of n is less than infinity. So going by such a definition, we have n is equal to minus infinity to plus infinity modulus of 2n u of n. We know that u of n exists only for positive values of n, hence rearranging it we get summation n equal to 0 to infinity 2 power n, and this particular value, it is quite clear from the mathematical geometric expression, it is going to be equal to infinity. So the system is not absolutely stable. Let us go on for the second problem to identify whether the system is stable or unstable. The question given is y of n is going to be equal to x of n plus 0.5 x of n minus 1 plus 0.25 x of n minus 2. This problem can be continued with a major substitution, namely we need to substitute x of n is going to be equal to delta n, which is an impulse input, and y of n is going to be equal to h of n, which is the impulse response. Considering this, what happens? We know that the requirement for stability is that the summation of h of n between minus infinity to plus infinity need to be finite for the system to be stable. So, since the system has values only at n equal to 0, 1 and 2, we will be analyzing only at these three values, as only at these three values there will be a finite value. So, let us go on to see what happens at h of n equal to 0. At n equal to 0, what happens is that we need to substitute it as y of n would become h of 0, that would be equal to x of n would become delta of 0 plus 0.5 x of n minus 1 would be delta 0 minus 1 plus 0.25 would be delta 0 minus 2. Here this would be delta 0, this would be delta minus 1, this would be delta minus 2. These two get cancelled because delta, as we know, is defined only as 0, hence the answer would be h of 0 would be 1. Similarly, let us calculate h of 1 and h of 2. At n equal to 1, the value of h of 1 would be delta of 1 plus 0.5 delta 1 minus 1 plus 0.25 delta 1 minus 2. This results in delta of 1, which is not defined, delta 1 minus 1, this is delta of 0, this exists, and this is delta 1 minus 2, which is delta of minus 1, this is also not defined, hence the answer would be 0.5 into delta 0, which is 0.5, so h of 1 is 0.5. And the last case is at n equal to 2, it would be h of 2 would be equal to delta of 2 plus 0.5 delta 2 minus 1 plus 0.25 delta 2 minus 2, as is going to be with respect to the substitution. Hence, these two effects would be nullified. The only effect would be because of this, that is 0.25 into delta 0, which is going to be 0.25. So, to calculate the effect of stability, we need to go on for the summation of h of n. Let us go on to the next discussion of the type of system, namely invertible system and non-invertible systems. A system is said to be invertible if it has a unique relationship between its input x of t or x of n and output y of t or y of n. In other words, a distinct input produces a distinct output. This could be represented in the form as, usually this is a system and y is the output and x is going to be the input. T or n is not shown because it could be extended for both cases. When we apply an inverse system, it states that it could be converted to back to x, resulting in an inverse system. Let us go on by an example by substituting y of t is going to be equal to 2x of t, which means here it would be 2, and if we consider the relationship between y and x, if it is 0.5, then we get back x, which is going to be y of t is going to be defined as 2 into x of t. Hence, this could be an inverse system as a distinct input produces a distinct output. Let us go on to consider another relation, which is a relation between the inductor y of t is going to be equal to 1 by L integral minus infinity to plus infinity x tau d tau. What would be the inverse operation definition? Let us go on to that. So we know that y of t is replaced by x of t, 1 by L is replaced by L, and integral is replaced by d by dt, and x tau is replaced by y of t, resulting in an inverse system. On the other hand, if we have an expression defined by y of t is equal to x square t, the inverse would be square root of x, which could be positive and negative. Since it is not distinct, it may not result in an invertible system. Next, let us go on for a quiz considering linear systems, nonlinear systems, stable and unstable systems, invertible and non-invertible system. Filter is an example of linear system, nonlinear system, both, none of the above. In our first slide discussion, we had considered that it is an example of a linear system, which means the answer is A. Next one, Bibo stability criteria states that the summation of integral minus infinity to plus infinity h of t dt modulus is less than infinity, which is going to end to 0, infinity, absolutely summable, or whether it will be unique. We know that it should be absolutely summable, or in other words it should be finite. Thus the answers are 1A and 2. So these are our solutions, 1A and 2C, as discussed in the previous slide. And these are our references, Oppenheim and Simon Aiken.